Welcome to SST Pathshala, this comprehensive session on the Sun and stars. Today, we will examine the essential roles played by the Sun in our solar system and explore the intriguing process of star formation. The Sun's role and star birth. This presentation will equip you with a deep understanding of the Sun's anatomy and its significance within the solar system. Additionally, we shall discuss how stars, including our Sun, are formed and evolve through cosmic timescales. Knowledge acquisition. Let us initiate our inquiry by identifying and analyzing the structural composition of the Sun. Understanding its core functions will provide clarity on its impact on the solar system at large. Comprehension and exploration. In this segment, we will demystify concepts such as solar wind, solar radiation, and the sophisticated mechanisms behind the Sun's energy production. These phenomena are not only fascinating, but vital for sustaining planetary environments. Performance objectives. By the conclusion of this lesson, you should be able to illustrate the processes underlying the formation and evolution of the Sun, other stars, and entire galaxies. Think, pair, share exercise. Please reflect on the following. What materials constitute the Sun? In what ways does the Sun influence life on Earth? Engage in meaningful discourse with peers, sharing reasoned ideas and scientific perspectives. Group sharing. After collaborative discussions, individuals are encouraged to articulate their viewpoints, fostering a collective understanding of the Sun's composition and ecological importance. The Sun's mass. Consider this statistic. The Sun comprises approximately 99.86% of the total mass in our solar system. The remainder, all planets, moons, and smaller bodies, accounts for a mere fraction compared to our monumental star. Overview of the solar system. Our solar system is a dynamic structure consisting of the Sun and all celestial bodies that orbit it. 8 principal planets, their satellites, various dwarf planets, comets, and asteroids. The Sun anchors this system and provides indispensable energy for life on Earth. Inner planets, Mercury, Venus, Earth, Mars, are characterized by rocky surfaces, whereas outer planets, Jupiter, Saturn, Uranus, Neptune, are massive gas giants. Beyond Neptune lie the Kuiper Belt and Oort cloud, domains of icy objects such as Pluto. The Sun's core. At the heart of the Sun lies its core, where nuclear fusion transpires. Through this process, hydrogen nuclei combine to form helium, producing immense light and thermal energy. The core powers the Sun and, by extension, energizes the solar system. Radiative zone. Encircling the core is the radiative zone. Energy generated within the core transits this layer slowly, predominantly as electromagnetic radiation. It may require millions of years for energy to journey outward through this dense region. Role of the radiative zone. This intermediary region is fundamental to energy transfer, ensuring the gradual outward movement of energy from the Sun's vibrant center to its exterior layers. Convective zone. The convective zone, outermost among the Sun's internal layers, facilitates heat transfer through convection. Hot, ionized plasma ascends to the surface, cools, and cycles back downward, regulating the Sun's thermal dynamics. The Sun's corona. The corona, the Sun's extended atmospheric outer layer, boasts temperatures exceeding those at the Sun's surface. It emits the solar wind, a continuous outflow of charged particles permeating our solar system. Solar wind. Solar wind, composed of charged particles, is perpetually emitted from the corona. These particles interact with planetary magnetospheres, triggering phenomena like Earth's auroras. Coronal mass ejection, CME. A coronal mass ejection represents a dramatic expulsion of solar wind and magnetic fields. Particularly intense CMEs have the potential to disrupt Earth's magnetosphere and impact technological infrastructure, such as satellites and communication networks. Solar radiation. Solar radiation encompasses the spectrum of energy released by the sun, including visible light and heat. This energy sustains terrestrial life, enables photosynthesis, powers the water cycle, and influences Earth's climate. The Sun's life cycle. Nebula stage. The genesis of the Sun traces back approximately 4.6 billion years to a nebula, a vast molecular cloud predominantly composed of hydrogen, the initial fuel for subsequent fusion. Protostar stage. Within the nebula, gravitational forces induced aggregation, increasing heat and density until a protostar emerged. Fusion processes had not yet commenced during this phase. Main sequence phase. Presently, the Sun is in its main sequence phase, marked by stable hydrogen fusion. This epoch, now 4.6 billion years underway, will persist for several billion more years. Red giant phase. Eventually, as core hydrogen depletes, the Sun will swell into a red giant, dramatically enlarging after approximately 5 billion further years. Planetary nebula and white dwarf. As helium within the Sun is exhausted, outer layers will dissipate, leaving a planetary nebula. The remnant is a white dwarf, a dense, luminous core. Lacking sufficient mass, the Sun cannot become a black hole. Its ultimate fate is to exist as a white dwarf. Thank you for your intellectual engagement in this session on the Sun and stars. Continue to delve into resources and cultivate a deeper understanding of our universe. Resources. Feel free to consult the recommended references and tools